Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to solve quadratic inequalities algebraically. Let's consider the following problem, where to solve the given quadratic inequality algebraically. Alright, so let's say we have the inequality negative 3x squared minus 4x is greater than negative 4. Okay, let's write down the steps that are going to guide our problem solving process. So the steps are as follows. First thing to do when solving quadratic inequalities algebraically involves finding the critical values. Okay, so you find the critical values. Step number 2, you're going to use the critical values to create intervals. So use the critical values to create intervals. Now, what are your intervals for? Well, your intervals are to create test regions that you can ascertain where the inequality is valid. So step 3, we're going to test the intervals to see which satisfies the inequality and write our solution from our test. Okay, and write solution. Okay, let's go ahead and get started. We'll start with step 1, which is to find the critical values. How do you find the critical values? To find the critical values, you simply set the inequality equal to 0 and solve. Okay, set equal to 0 and solve. Now, if you take a look at what we have here, this is an inequality. We're starting with the inequality negative 3x squared minus 4x is greater than negative 4. To set this equal to 0, the first step involves changing this inequality to an equality. So 3x squared minus 4x equals negative 4. And now we'll set it equal to 0. This can be accomplished by adding 4 to both sides. So we have negative 3x squared minus 4x plus 4 equals 0. So now we've accomplished the setting equal to 0 component of the first step. Now to find the critical values, we have to solve this equation. We're going to use the factoring method here, so let's use the x gain. Set up our x gain so we can write this as a quadratic with 4 terms that can be factored by grouping. AC goes on the top. AC is negative 12. So we have negative 12 for AC, and B is negative 4. Okay, so in this quadratic we have in general form, note that A is negative 3, the coefficient of x squared, B is negative 4, and C is positive 4. Okay, so AC goes on the top, B goes on the bottom. Now we're going to figure out two numbers, then multiply to give you negative 12 and add to give you negative 4. So let's use 6 and 2. In order for the sum to be negative, the bigger has to be negative. Insert that into the quadratic equation. We'll have negative 3x squared minus 6x plus 2x plus 4 equals 0. Alright, now we have 4 terms. We can split it down the center and factor by grouping. From the first two, we can factor out the GCF, which is you keep the sign of the first term always negative. We can pull out 3 and then an x. We will be left with x plus 2. Okay? From the two terms to the right of the partition, we can factor out the GCF, which is 2, and we'll be left with x plus 2. This looks correct because the quantities in the parentheses are identical. So we'll factor that out. That gives us x plus 2. And the terms on the outside, we'll group them together in their own parentheses. Negative 3x plus 2 equals 0. Now using the zero product property, we'll set both factors equal to 0 and solve. For the first one, we subtract 2 from both sides. That gives us the first critical value of negative 2. For the second one, we'll subtract 2 first. Negative 3x equals negative 2, and then divide by negative 3. That gives us our second critical value. X equals minus over minus is plus 2/3. Okay, so you slash and dash to the left side and then slash and dash on the right. Remember, when you divide two signs that are identical, you always end up with positive. Okay? Alright, so we found our critical values. So let's write that down. Our critical values are x equals negative 2 and x equals 2/3. Now we are done with step number 1. We're now going to advance to step 2, which is to use the critical values to create intervals. Okay? Alright. So let's go ahead and do that. We're going to set up our interval. And then let's put down our critical values. We have negative 2 and 2/3. So let's say it's 0, 1, 1, 2, 1. So let's make this 0. 1, 2, 3. Let's call that negative 1. And then 1, 2, 3. That's negative 2. That's our first critical value, and then the next one is 1, 2, 3. That's positive 1, and then positive 2/3 is somewhere here. Okay. All right. So we have our critical values at negative 2 and positive 2/3. So let's split our interval, our number line, using these critical values. Okay. So they're going up this way. Alright, so what we've created is 3 intervals using our critical values. So the question is, which intervals or intervals satisfy the given inequality? So which inequality are we considering here? We're talking about the original. Okay, so let's go ahead and label our intervals. This is interval number 1. Any number to the left of negative 2. Interval 2 is any number between negative 2 and positive 2/3. And interval 3, any number bigger than 2/3. Now we're going to pick test candidates that we use to ascertain which interval satisfies the original inequality. To the left of negative 2, I can pick any number. I will select x equals negative 3. For the sake of simplicity, in interval 2, I will pick x equals 0. In interval 3, I will select x equals 1. Okay, now we have our interval set up. We're now going to go ahead and proceed with step 3, which is to test our intervals. Okay, So let's write down step 2. Step 2 was to create intervals. Okay? And now for step 3, we're now going to test the intervals to see which one satisfies the original inequality. Okay? Alright, we're going to start with interval number 1. Interval 1 is any number that falls in this entire region right here. We've just selected one, namely -3. Alright, let's test it. So for interval 1, we have we're testing x equals -3. And don't forget the equation that we're testing. We're testing the original inequality, -3x squared minus 4x is greater than -4. Okay, so to test it, we'll substitute x into this inequality. We'll have -3 times -3 squared minus 4 times -3. The question is it bigger than -4? Is it? Let's see. So we simplify using the order of operations. On the left side, we have -3 times 9. Minus times minus becomes a plus 12. Is this greater than -4? And -3 times 9 is -27 plus 12. Is that greater than -4? If we subtract these two, we get -15. Is -15 greater than -4? This is more negative than this, so this statement is false. Okay? So put the cross right here. So what does this tell us? It tells us that interval number 1 is no good. The numbers in this interval do not satisfy the original inequality. Okay, let's advance to our next test interval, which is interval number 2. So what number did we select to test for interval 2? We selected the value x equals 0. Does it satisfy this inequality right here? Let's see. So we have -3 times 0 squared minus 4 times 0. Is it greater than -4? Simplifying. -3 times 0 squared is 0, minus 4 times 0 is 0. Is this greater than -4? 0 minus 0 is 0. Is 0 greater than -4? Absolutely. This inequality is true, which tells us that this interval contains values that satisfy our initial inequality. Put a check mark. And lastly, let's take a look at the last interval, interval 3. For interval 3, we selected x equals 1. Let's see if that satisfies the inequality. So -3 times 1 squared minus 4 times 1. Is it greater than -4? Let's simplify. -3 minus 4. Is it greater than -4? Is -7 greater than -4? The answer is no. -7 is to the left of -4 on the number line, which means this inequality is false, which automatically implies that any numerical value in this interval will not satisfy the original inequality. Okay? Now, the inequality does not have a line underneath it, so we're going to have an open circle scenario. So to illustrate our solution region graphically, we'll have the endpoints excluded. So we have an open circle here and an open circle here and everything that's in between. Okay, let's put the green line. So any number that's in between -2 and 2/3, excluding the boundary values, will satisfy our inequality. Okay? So there are two ways that we can write down our solution. We can write it as two separate inequalities or a compound inequality. Alright, so our solution is, you can say x is greater than negative 2 because it's to the right of negative 2, and x is less than 2/3 because it's to the left of 2/3. Okay, if you look at our compound inequality, the x values that satisfy the inequality are to the right of negative 2, which indicates greater. Okay, so in this direction is greater, and to the left of 2/3, which indicates less. So it's a combination of these two. Or you can write it as a compound inequality, which is negative 2 is less than x, and x is less than 2/3. So any one of these two formats of expressing your solution interval will suffice. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of quadratic inequalities, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this tutorial or any Algebra 2 concepts in general, just place your questions in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.